This is Sukesh Kulkarni, and you are watching Cosmic Science. You might have seen how aeroplanes take off and how they land. You might be knowing. So I'll explain the working of that, what forces are involved in that, how it works, how is the physics behind that. I'll give you an example one. Suppose this is an aeroplane. It has three wheels. When these three wheels start moving, it takes the aeroplane ahead. So these wheels are acting against the friction and displacing the aeroplane. What does this mean? This means that force and displacement, they are called work. Force into displacement, this is called work. As it takes off, here these engines, they work very hard, they are very powerful, they're very powerful, and they take the air coming in front of it and sends it back, and gives a forward motion for the plane, with the help of uh, aerodynamic system. So these engines work and produce force and displaces the uh, aeroplane, uh, to around 20, no, not 20, it's about uh, 4 5 kilometers in 10 minutes. But here in this case, these travel, make aeroplane travel with a speed of 120 kilometers per hour or 140 kilometers per hour. So the time taken to do the work is called power. Let me tell you it clearly. It takes very less time to make this plane to move ahead, and here these wheels take a lot of time to move the plane ahead. So these wheels have very less power, and these engines are used in power. So here we can see that work, energy, and power are correlated. So this will be today's topic, and I'll be doing videos on this topic, that is work, work, energy, and power. We'll be dealing with work, energy, and power. I gave you example. This is responsible for these wheels are responsible for a plane to move forward, and it also consists of potential energy, uh, not potential, kinetic energy, and this possesses kinetic energy plus potential energy, because it is at the height of, it is height of h from here. It possesses kinetic energy, it possesses kinetic energy plus potential energy. So this energy, force applied by this wheels, and work done by force, and the displacement it takes, this, if I combine these all, I get work, energy, and power. So we'll be discussing in detail about it. Before moving ahead, there are there are some concepts which are important to understand this work, energy, and power. There are some of the mathematical tools required to calculate work, energy, and power. So we need to learn some mathematical tools. We'll see ahead of this. Okay. Let me tell you. We'll be working on vectors and scalars first. What is a vector? It is a physical quantity which has both direction and magnitude. What does it mean? if a body moves in a straight line, if a body moves in a straight line with with a velocity 30 kilometers per hour, velocity it moves its velocity is 30 kilometers per hour, and this is a vector quantity because it is in this direction, dependent on direction. Magnitude is dependent on direction is called a vector. Suppose there is a vehicle. There is a vehicle here. It's moving, and its path is not fixed. It's moving, and its path is not fixed, but it is moving with a particular amount of speed. Suppose 120 kilometers per hour. It's moving with 120 kilometers per hour. So it has magnitude, but it doesn't have a fixed direction. It can move like this or any other direction. So it is called scalar. So now it is necessary for us to multiply this magnitude as well as direction. So scalars and vectors, we need to multiply this. Multiply in the sense uh, we give both value to the vector and vector to the value. Let's see how we calculate scalar product. In the sense how we multiply a vector with having magnitude as well as direction. How we multiply it, we'll see in coming here. Scalar product or dot product. Scalar product or dot product. To say to calculate this scalar product or dot product, we need to take two vectors. They are 3i plus 4j minus 3k, and another vector we need 2i minus 3j plus 4k. These are the two vectors, right? So we need to multiply these two. We take it as vector A dot vector B. We are taking a dot product here. What does dot product mean? We are multiplying two vectors to get a scalar quantity, that is magnitude. Two I minus 3j plus 4k. Now we need to multiply this. How will you multiply this? This 3 with this 2, with this 4 with this 3 minus 3, this minus 3 with this plus 4. We multiplied it. This is how it goes. 3 2s are 6 plus 4 3s are 12, but here it is minus sign. 12j minus 3 into plus 4 minus 12. We need to put cap on this so that we indicate it is a vector quantity. We need to put this cap to represent it is a vector quantity. So now we can say that we have multiplied. So now we are going to take only magnitude here. This 6 minus 12 minus 12. How much does it go? How much does it go? It will be some value here. It will here we get some value. Here we get some value which will be in a number. It will be in magnitude. So scalar product or dot product is called also called it also gives a dot product and magnitude of these two vectors. So once again I'll explain you. I have taken two vectors A and B. I have taken dot product of that. Dot product means multiplying two vectors to get a scalar quantity. Uh, this is one vector, this is one vector. We have multiplied this vector with this with this with this, and we get value like this. And we only take here magnitude. And when we solve this, we get a value here, which is a magnitude. So it means that we are multiplied this, and we got a magnitude of this value. So this is clear about scalar product. Let us move to the vector product. Or vector product or cross product. Vector product or cross product. If I consider two vectors, vector A 3i minus 4j plus 3k. Don't forget to keep mark a cap on the vector. And B vector 2 2i minus 3j plus 4k. So we are going to take a product of this, and we will find again a vector. A vector A cross vector B. How do we solve this? This is our two vectors. How do we solve this? It is solved by matrix method. You might have familiar with that. We use matrix method. So first one, we need to take, now we have taken here vectors. Now we have to take magnitude of this vector 3 minus 4 3, and magnitude of vector B 2 minus 3 plus 4. So how do you solve this matrix method? Suppose I into, we need to calculate I, so we need to leave this row, this column with this row. We get minus 4 plus 4, minus 4 minus 4 into plus 4, minus 3 into 3, minus 3 into 3, plus j component. We for j component we leave this column, this row. We take 3 fours are minus 2 threes are. Now k. Now now we want the value of k vector. 3 into minus 3, 2 into minus 4. So let's solve this. I value minus 4 into plus 4, minus 16. Here it is minus 3 into 3. So 3 threes are 9. Here it is minus. Minus becomes plus. J. 3 fours are 12. 12 minus 6. Plus k. 3 into minus 3. Minus 9. Um, 2 into minus 4. Minus 8. Here it is minus sign. So it becomes plus 8. So when we solve this, we get I 24, J 6 plus k. Here it is minus 1. So final value will be final value will be 24 I 6j and and minus k. So this is the cross product. This is a cross product. This is a cross product of A and B. So this gives, when you multiply a vector and another vector, you get another vector, a new vector. But in case of dot product, that is scalar product, when you multiply these two vectors, you get a magnitude. You get a only value, not the vectors. So this was about vector product and cross product. So this was about today's part, and we'll be discussing ahead of this vector and scalar properties and other aspects of this. We'll see in the next video. Till then, keep watching. If you like my content and explanation, please do subscribe, comment down your feedback, and hit a like button. Thank you very much.